Hi guys, I just wanted to talk about how to calculate Z-scores associated with particular 95% confidence intervals from Module 5. So if you're asked to find a 95% confidence interval, first of all, once you've found the standard error by dividing the population distribution, once you've found the standard error by dividing the population standard deviation by the square root of n, or the sample standard deviation by the square root of n if n is greater than 30. So you found the standard error, you then need to multiply the standard of error by z to get the margin of error. And z will vary depending on whether you're looking for a 90% confidence interval, a 95% confidence interval, or a 99% confidence interval. So you need to find z, which you can do so by hand using the standard normal distribution tables, or you can do so using Excel. So it's really tempting for students to go, okay, I'm going to find the z-score that's associated with an area of 95% being to the left of the z-score. So they really are trying to find the area associated. They go, okay, the z-score in which 95% of the values are to the left. And so they go to Excel and they type equals norm I. This gives you the area, the probability associated with a particular. This gives you the z-score associated with a particular probability. So they go norm equals norm I. Let me do it again for you and keep it there. Equals norm S I and V, and they go 0.95. And they think, right, that's going to give me the z-score associated with a 95% confidence interval. That's not actually correct, because we don't want to know this z-score here. We want to know this z-score here and here. Because the 5% of values that are not in the 95% confidence interval are split into two sides of the distribution. So there's 2.5% of the values here and 2.5% of the values here. So I'll just rub that bit out. So we want to know which z-scores are associated with the 2.5% point and here, and the 2.5% point here. So they'll be the same value, but one will be negative and one will be positive because the distribution is symmetrical. So instead of looking for the z-score associated with 0.95, we go equals norm SINV 0.975. So we take away 2.5% or 0.25 from 1 to get 0.975, or equals norm SINV 0.025 will give you the same value but negative. So that's why the z-score that's associated with the 95% confidence interval is 1.96, because that's what that value is rounded to 2 decimal places. So you actually need to subtract the area, the confidence interval, in this case 0.95, from 1 to get 5%, and then you need to divide it by 2 to get the 2.5%. And it's that 2.5%. You need to find a z-score that's associated with the area to the left, where the area to the left of that z-score is 2.5%, or the area to the right of that z-score is 2.5%. So that z-score will be 1.96. So hopefully that clarifies for you a little bit. This will come up a lot in Module 6, because in Module 6 you'll be looking at one-tailed and two-tailed tests. So if the hypothesis is directional, it will be a one-tailed test. You're predicting that the z-score for the sample that you're comparing to will be on this side of the this side of this distribution, if you're saying that the sample comes from a population with a mean that's higher than the population to which you are comparing it, or it'll be if you say that the sample comes from a population with a mean that's lower than the population to which you are comparing, then it will be down this side. So the 5% will only be up on one end of the tail, not in two ends of the tail. And this is called a one-tailed distribution. If it's a non-directional hypothesis and you're just saying that your sample comes from a population with a different mean, but you're not hypothesizing whether that mean is higher or lower, it's a non-directional hypothesis, and you need a two-tailed test for that, which is what we've been talking about today. We've been talking about two-tailed tests. So you need to be reasonably aware of the difference between one-tailed and two-tailed tests, particularly when we go into Module 6 and particularly for the exam. And the way you tell is whether it's a directional hypothesis or not.